So this is the journal article critic for the subject numerical methods in engineering. The article title is a comparative study on Gauss elimination method and simplex method of linear optimization problem. The researchers are as follows and shown below. We have Rahidas Kumar, Sadeo Mato, this is published way back 2017, volume 47, number 1 of the IJMTT, or International Journal of Mathematics, Trends and Technology. So it still covers the 5-year coverage from 2022. This paper deals a new approach for the solution of the linear optimization problem with the help of Gauss elimination method of matrix. This method is based on the square matrix, which converted into upper triangular matrix by elementary role transformation. This method we get direct solution without any iteration. Also, we show that this method is better than the simplex method. So basically, this journal is a brief comparison between the Gauss elimination and the simplex. As we all know that the Gauss elimination method, as has been discussed by our professor, Dr. Region, it's almost, in fact, really identical with what they're pertaining to here. So there is a conversion, there is a construction of augmented matrix from A and B, and they also use the variables Ux is equivalent to B. Then from that substitution, they'll get the actual solution. We have a sample solution using Gauss elimination method. Here in the upper left corner, you'll see the 3x3 matrix, which consists of variables x1, 2, and x3. All are equivalent to 8, 10, and 15 respectively. Now, if you could see, the entire transformation per row is very similar to one that we are using. So here you could see that there are 1 and 2 iterations. From there, nakukuha na natin yung sagot and the solution. If you could see, we have x1 is equivalent to 89 over 41, x2 50 over 41, and x3 is equivalent to 62 over 41. We didn't have enough time to consider studying the method of the simplex method. However, simplex method, it states here, and there are several iterations that has been considered using the simplex method. The easiest way for us to see is by example. Now, if we go back with the Gauss elimination method using the same matrix, the 2, 3, 0, 0, 2, 5, 3, 2, 5 equal to 8, 10, 15 respectively. We've used the same here using the, this should be not Gauss eliminations, this should be simplex method already. This is typographical error. So, mapapansin natin dito, there is an introduction of several variables, particularly, or specifically S1, S2, and S3. The initial basic feasible solution for XB, which is another variable, is equivalent to S1, S2, S3 in a matrix form, equivalent to 8, 10, and 15. So as we move on, there is a rather different method of representing its variables and its solution by using tables. So here on the table 1, the initial iteration, plotting the x1, 2, 3, particularly in S2, S1, and S3, crisscross referencing of 2, 3, 0, 0, 2, 5. I don't have a mouse here, but we are pertaining to the column on the 1, 2, 3, 4th row, 1, 2, 3, 4, 5th column of table 1. So makikita natin doon the x1, x2, and x3. We have 2, 3, 0, 0, 2, 5, 3, 2, 4. Now, subsequently plotted on its side is the S1, 2, 3, following the same inverted matrix, following the same pattern of matrix of 1, 0, 0, 0, 1, 0, and 0, 0, 1. So, very similar din siya dun sa may LU decomposition na method na ginagamit natin. You could see that there is introduction of x2 by simply dropping the s1 here in the table 2. Now, x2 under s1, so yung mag-crisscross tayo sa x2 and s1, x2 for the column and x1 for the row, you divide it by 3, kaya lalabas na yung 1 dito under x2. And then you divide it also with the other variables, so thus you could have seen here the 2/3, 8/3, and the 1/3 for the S1. So itong pattern na to, ito lang yung parang sinusundan natin at until makuha natin yung 1, 0, 0, 0, 1, 0, and 0, 0, 1 dito. So from our second iteration, this is we have the second table. The third iteration, again, following the same pattern, and up until the fourth iteration by dropping the S2 and S3 and introducing X3 and X1 simultaneously. Now, there is a bit unorthodox substitution, or let's say, inuna niya dito na nag-substitute and drinap is the X2 instead of S1. I don't know with the simplex method is, but they use the X2 first. With this, you could see on the lower right portion of the screen the solution. X1 is 8941, X2 is 6241, and X3 is 5041. Comparing with our Gauss elimination method, the answer are exactly the same. Forgive my typographical error here. This one should be simplex method. I'm sorry. Now, comparing Gauss elimination and simplex method, first the similarity, both methods are doing step by step. Both methods give us an actual solution. Obviously, they have the same answer. The difference, simplex method, we introduce slack variables, yun yung S1, S2, and S3 natin. But in the Gauss elimination method, we cannot use any extra variables. In simplex method, we have to take at least 2 iterations. So, yun yung napansin natin dito kanina, iteration. We have this first iteration, and then on the second iteration, we already have these sets of solution. Well, that is assuming row 2, column 1, we already have 0 there. So, in simplex method, yeah, ito. But in Gauss elimination, we have to take exactly 2 iteration. Conclusion. Gauss elimination method has minimum calculations as compared to simplex method. Also, this method has simple calculation compared to the simplex method. Ironically, sinabi siyang simplex pero it's more complicated. More and more useful of Gauss elimination method becomes very mechanical. Thus, Gauss elimination method is far faster than the simplex method. That concludes the presentation, the pre-recorded video for this journal article critic. Thank you for listening.